Hi, my name is Samuel Salom and today I'll be going through this Lapid tutorial. This tutorial will be about timing functions. Let's first talk about what are timing functions used for. Timing functions can be used to set the frequency in which loops execute. They also allow you to synchronize the execution of parallel loops, and they improve the processor performance. Let's see some of the most important functions from this group. We first have the wait millisecond function. This function waits until the specified time in the input has elapsed. So for example, in this example we have 100 milliseconds in the input, so we would first wait the 100 milliseconds, then run whichever subdiagram we have in the structure in which we place a function, and then repeat the process. So we would first wait 100 milliseconds, then run the subdiagram, then wait again 100 milliseconds for the next iteration, and run again the subdiagram. So this will allow, for example, if you have a while loop without this function, the while loop will run 1000 times per second, but this in this case would allow you to run it only 10 times, improving the performance of the processor. Now we will talk about some other functions such as the get, day, and time in seconds. This function gives you a timestamp of the current date and time. Using the conversion to double precision function, you can get the number of seconds elapsed since 12 a.m. of January 1st, 1904. The combination of these two can be really useful, especially when making an application involving a sequence of time events, like the traffic lights application or the car wash application. So this is really useful mostly when using the state machine architecture. We will talk about these kind of BIs later on in another tutorial. And another function would be the time delay function. This function inserts time delay into the column BI. So for example, in the left hand side of the screen we see a VI that once has run will then run the time delay, which will set a delay of 4 seconds before running the BI that is on the right hand. Okay, so let's first look at the first example. Here we have a while loop which has a numeric indicator wired to the iteration terminal and will run an infinite number of times per second since it has no timing function. Well, we first want to know or look at this example without the timing function. So this indicator will show us about how many times we'll run in the time that we're running. So in this short amount of time it ran more than 2 million times the while loop. So let's now add a wait millisecond function to regulate the amount of times it will iterate per second. We create a constant and we'll have 100 milliseconds, so in each second should iterate 10 times. And it did. This function will allow you to synchronize and use in a better way your computer processor. Let's now look at the get, day, and time function. Let's create an indicator so you can see the data type, and if we run it we will get the current time, which is 8:35 p.m. and the date. Now if you use the conversions function from the numeric palette and you use double precision, you can get the amount of seconds elapsed since 1904. So let's use this function to see how we can use synchronization, or we can use it in synchronization applications. So let's first create a while loop and use the add function, and let's place a shift register and wire the output of the add function to the shift register. Now we'll place another get date and time function with the double conversion inside of the while loop and compare it with the comparison subpalette using the less than or equal. So if the top input is less than or equal to the bottom one, the while loop will stop. Now this will be the time right here where I'm selecting in which the while loop or the application will start running, and this will give the current time each iteration. So we'll add 10 seconds to that time, so in 10 seconds the while loop should stop, since we're adding 10 seconds ahead to the current seconds elapsed since 1904, and by the time those 10 seconds have elapsed, this time will be either equal or greater than the time in which the while loop start running. Now let's wire this value to the other side of the shift register so we can now run our program. This should stop in 10 seconds. So we'll wait and see the way it does it, and then we'll use the highlight execution. And it did. Now let's turn highlight execution so you can see how it works. Gets the value, it compares it, and the first one will get false, of course. Then gets the same value until the time has elapsed, and then it stops. You can use this especially in state machine applications where you can use sequential events, and you don't necessarily want to use a sequence structure because the next state will depend on what happens in that state. So you have one, you're in the first stage, and you want to go to either 3 or 2 depending on what happens. And this is really useful whenever you're changing states in, for example, the traffic light application. Let's now look at the last function, which is the time delay. You could have the delay set by this dialog box or with an input, or for example, let's say 5.25. Okay, it's already set, so you don't need to wire anything, and you use a VI that has an error in or out, error in and out, input and output. Let's say, for example, let's use a VI that we have. Let's use angle VR. For example, if you use this one, you will not be able to use it because you only have numeric inputs, and if you wire it, there's going to be a broken arrow. So we have to look for one that has those inputs. For example, let's use the same time delay function. This function will wait the specified time before running the other function. So if you want to have a gap of time between 2 BIs running, you may use this function to either run other functions or VIs while the time is being waited, or to just synchronize other applications. This will conclude this tutorial. Thank you for watching.